طيب يعطيكم العافية. هلا إن شاء الله بنكمل الجزء الأخير من محاضرات الأنتيبيوتكس. والمحاضرة الأخيرة راح أحكي فيها إن شاء الله عن السلفونامايدز والميسيلينيوس antimicrobial agents or antibiotics. السلفونامايدز in general they were discovered by a scientist that's called Gerhard Domag, where he had a theory. كان بهذا الوقت بيشتغل مع شركة باير، وباير بال 1930 كانت موجودة جزء من شركة كيماويات أخرى. هلا هذا الساينتست كان عنده idea إنه certain observation كان في بعض الصبغات كانت يستخدمها بصناعة المواد الطعام ومواد الكيماويات. كان في certain dyes فعليا إنه when they put them على البكتيريا it stains only bacteria and doesn't stain الميديا or doesn't stain مثلا الوول تبعت البتري dish. It doesn't stain the hands, so it only stains the bacteria. So his idea was maybe some of those dyes are selective to bacteria. They like bacteria only. And if they like bacteria مثلا وبحبوا البكتيريا, why not discover something that will only go inside the bacteria, kill the bacteria, and doesn't affect human being. So that was his idea. So basically he screened with this company, the Bayer company, screened about 1000 dyes total, يعني حوالي 1000 compounds they were استخدموهم كصبغات، وكانوا كلهم فيهم functional group that we call azo group, which is two nitrogens connected to each other with a double bond. We call it as an azo. So that azo dyes من ال 1000 compound اللي استخدمهم, he found one of them that's called a red dye, or the chemical name for that compound is Prontosil rubberum. This red dye وهي صبغة حمراء لقى انها بتشتغل على البكتيريا. هلا لما استخدمها بالبتري ديش لقى انها ما بتشتغل دايركتلي على البتري ديش، ما بتعمل killing للبكتيريا. it does only goes inside the bacteria and stains the bacteria, but it doesn't kill the bacteria. Later on he took this dye قرر يجربها على mice infected with a specific bacteria، ولقى انها it kills this bacteria and stops the mice from dying, specifically a bacteria that we call hemolytic streptococcus that can infect المايس. So لقى الانفكتد مايس لما اجى استخدم الداي عليهم it can kill the bacteria and it can make the mouse survive this infection. So later on was he discovered, or he announced that he found a compound that can work as antimicrobial agent for streptococcal infection in mice. And فعليا we found later on that this compound structure was this Prontosil rubberum. And you can see this is a bicyclic compound or that has two phenyls and other substitutions. اللي بيهمني تعرف منهم اللي هي sulfonamide. This is what we call as sulfonamide moiety, and that's why this whole group of antibiotics called as sulfonamides. So this sulfonamide is the one that's sulfonamide part فعليا هون over here is the one that's active, and the other parts are not active, or they don't have any activity. So this drug, Prontosil, is a prodrug. Itself is not active in killing bacteria. When it's getting exposed to the liver reductase enzyme اللي موجود بالmice, it was found to degrade this compound Prontosil to the active moiety, which is the sulfanilamide. Sulfanilamide is a structure, as you can see, very simple structure that has a phenyl ring, and sulfonamide, as we can see, the sulfonamide moiety, and you have a para-amine on this structure. So it's a para-amine phenyl sulfonamide, or para-amine phenyl sulfonamide. This is the structure of that compound, which is called as sulfanilamide. So this is the active moiety. This is a prodrug. That's why it didn't work على bacteria on a petri dish, because you need this liver reductase enzyme اللي موجود بالmice to convert your Prontosil to the active moiety, which is the sulfanilamide. And the sulfanilamide structure over here, you can see, is a compound, very simple compound with an amine on the para position of this sulfonamide or phenyl sulfonamides. So that's why this didn't work على petri dish. It only worked على mice when it was administered or injected into the mice and protected the mice from this bacterial infection, streptococcal bacterial infection. What is the mechanism of action of these compounds, sulfonamides in general? Uh, Later on, طبعا, in 3 or 4 years later, they were able to find the mechanism of action, and the mechanism of action was around an idea. The structure of this compound, اللي هو sulfanilamide, very similar to another compound that we call para-aminobenzoic acid, or what's abbreviated as PAPA. And this PAPA compound, the para-aminobenzoic acid, is very similar in structure to the sulfanilamide. So these sulfonamide derivatives, or let's say sulfanilamide, which is the first one, are analogues of this para-aminobenzoic acid. لما نحكي analogues هم مشابهين بالستركشر بس مش نفس الكومباوند. طيب شو وظيفة من هذا السيميلاريتيز they were able to find the mechanism, and the mechanism of this compound that it works by inhibition of something that's necessary for the survival of this bacteria. It works by the inhibition of an enzyme that we call dihydropteroate synthase. This dihydropteroate synthase, it uses PAPA, اللي هو para-aminobenzoic acid, to synthesize الفوليك acid أو tetrahydrofolic acid, which is necessary for building or for synthesis of thymidine, DNA base, or a base that's necessary for building of the DNA. طيب إذن this compound اللي هو sulfanilamide work by inhibition of dihydropteroate synthase, and its mechanism of action comes from the structural resemblance of this sulfonamides with the para-aminobenzoic acid, which is the natural substrate for that enzyme that's used to build, which is part of the synthesis of this folic acid. So sulfonamides cause a production of defective products, يعني inactive products, because they resemble البابا. So بيقدروا يستخدموهم الانزيم اللي هو dihydropteroate synthase بيروح بيستخدم السلفونيلاميد بدل بابا, and it stops the production of tetrahydrofolic acid. This mechanism, as you know from مثلا pharmacology or other subjects, is called competitive inhibitor of PAPA. ليش competitive inhibitor؟ لأنه فعليا هو بتنافس مع البابا for this enzyme اللي هو dihydropteroate synthase, وبيرتبط على الدايهيدروبتيرويت سينثيز وبيخلي الدايهيدروبتيرويت سينثيز يتهيأ له أو يعتقد إنه هو this is the substrate, the natural substrate with this PAPA, وراح يستخدمه for the synthesis. بس البرودكت اللي راح يطلع فعليا inactive product is not the correct product. So these compounds are bacteriostatic, they're not bactericidals, because they prevent the folate coenzyme synthesis, they prevent the folic acid synthesis, which is necessary for the synthesis of deoxythymidine DNA base, and so you prevent DNA synthesis and you stop the DNA synthesis. خلينا نشوف الميكانيزم. This is the dihydroteroate diphosphate, the natural ligand, and this is PAPA, the others, the second natural ligand. So these two natural ligands, they need the enzyme اللي هو dihydropteroate synthase. هذا الحكي موجود inside the bacteria. This enzyme is inside the bacteria, where it couples those two compounds. تربط هذول التو compounds البابا مع الدايهيدروبتيرويت دايفوسفيت عشان ينتج منه dihydropteroic acid, والdihydropteroic acid is converted to tetrahydrofolic acid, or the folic acid that's necessary for the synthesis of thymidine, and following this thymidine is necessary also for the synthesis of DNA. وين السلفوناميد بيشتغلوا زي ما حكينا؟ They work as competitive inhibitor for this dihydropteroate synthase. They bind to this enzyme. They produce an inactive product that's not dihydropteroic acid, but they stop the synthesis of tetrahydrofolic acid. They stop the synthesis of thymidine, and then they stop the synthesis of DNA. ليش؟ لأنهم they resemble structure-wise, they resemble para-aminobenzoic acid, and so they can bind to this enzyme dihydropteroate synthase ويرتبطوا على الدايهيدروبتيرويت دايفوسفيت وينتج لنا برودكت خاطئ مش الدايهيدروبتيرويك acid, which is inactive and doesn't produce a tetrahydrofolic acid. So another demonstration how does the يعني فعليا هون بس عشان نوضح أكثر كيف التتراهيدروفوليك acid being synthesized in the bacteria. في عنا dihydropteroate diphosphate. Again it's a substrate for the enzyme dihydropteroate synthase. بيجي بياخد الدايهيدروبتيرويت دايفوسفيت مع البابا بوجود الإنزيم بيخلي هذا التفاعل يحصل، اللي هو الأمين والأتاك this carbon release الدايفوسفيت، راح يطلع دايهيدروفوسفيت دايفوسفيت or dihydrophosphate doesn't matter، وراح ينتج عنا هذا الدايهيدروبتيرويك أسيد. الدايهيدروبتيرويك أسيد is the ligand that will be used further. طبعا هذا by an enzyme that we called a dihydropteroate synthase، لأنه هو اللي بيصنع لنا الدايهيدروبتيرويك أسيد. هذا الانزيم اللي هو بيصير له inhibition by sulfanilamide. Either way, dihydropteroic acid will be reacted with glutamic acid with another enzyme that we call dihydrofolic acid synthase that will couple dihydropteroic acid مع glutamic acid عشان يعطينا dihydrofolic acid اللي هو مهم جدا للبكتيريا عشان تقدر تصنع الثايميدين تبعها. طبعا بتصير فينا dihydrofolate reductase which is an additional step that converts dihydrofolic acid to tetrahydrofolic acid, followed by the next step which is a methylation of that tetrahydrofolic acid عشان نسميها methylene tetrahydrofolic acid. And tetrahydrofolic acid هو عبارة عن compound that's used just to transfer methyl in the thymidine synthesis, where we convert this نحول اليوريدين to thymidine with this co-substrate or coenzyme that transfers the methyl from to uridine to convert it to thymidine. فالتتراهيدروفوليك أسيد مهم جدا فعليا بالبكتيريا عشان تصنع الثايميدين. لكن اللي بدنا نحكي عنه هون اللي هو اليوم اللي هو this sulfonamides. sulfonamides بيجوا بيرتبطوا على هذا الانزيم وبيعملوا الانهبيشن اللي هو الدايهيدروبتيرويت سينثيز وبيصنعوا برودكت مختلف مش الدايهيدروبتيرويك اسيد، راح يكون نفس الستركشر بس الفرق بيناتهم ما في كاربوكسيليك اسيد. عندنا هون السلفونامايد فعليا لانه الانزيم بتهيأ له انه هذا زيه زي البابا نفس الستركشر، بيستخدمه for the synthesis produces a compound with not carboxylic acid with sulfonamide فعليا. تمام. that produced compound is inactive or that produced derivative is inactive for the synthesis of tetrahydrofolic acid, and so the bacteria cannot synthesize الثايميدين for its DNA. طيب السؤال المهم انه ليش السلفونيلامايدز ما بيأثروا على الهيومن سيلز؟ مش احنا عندنا كمان ثايميدين وبنحتاج synthesis for the thymidine tetrahydrofolic acid. basically لانه الانسان ما بيصنع بهاي البروسيس tetrahydrofolic acid. tetrahydrofolic acid بناخده فعليا من النباتات ومن الفود، فعليا السورس تبعنا. احنا ما بنصنع tetrahydrofolic acid بهاي الطريقة فعليا. جسم الانسان فيه tetrahydrofolic acid بياخده directly من النباتات ومن السورس of food, and so we don't really need this synthesis, so we don't have this enzyme dihydropteroate synthase, and that's only in bacteria, and that's why these compounds sulfonamides are selective for bacteria and they don't affect human cells or synthesis of the DNA of human cells. Again, a tetrahydrofolic acid or a dihydrofolic acid can be obtained, any of them, dihydrofolic acid or tetrahydrofolic acid, can be obtained from a dietary source اللي هو الفوليك acid فعليا, and that's why we don't need these enzymes اللي هو specifically dihydropteroate.
طيب إذا زي ما حكينا السلفونامايدز these are competitive inhibitors of the PAPA which is another substrate in the for the enzyme that we call dihydropteroate synthase. هلا عشان السلفونامايد يشتغلوا لازم يمروا عشان يقدروا يعملوا inhibition لهذا الانزيم لازم يصير لهم absorption through the bacterial cells, and this is usually happened by passive diffusion. To do this process you need to have your compound to be relatively lipophilic. So the lipophilicity of sulfonamides are obtained through the benzene ring. وجود البنزين ring بالsulfonamides is very important for the lipophilicity of the structure, which allows sulfonamide to partition through the bacterial cell walls or to diffuse through the bacterial cell walls and find their target enzyme, which is the dihydropteroate synthase enzyme. هلا زي ما حكينا الsulfonamides these are analogues for the natural substrate which we call as PAPA, and you can see the similarities. Both have amines and both have phenyl rings, and then the difference is one has a carboxylic acid in the natural ligand البابا بينما الsulfonamide موجودة بالsulfonilamide which is the antimicrobial agent. الsulfonamide ما بعرف يعني how many of you would probably know this information، بس السلفونامايد is فيها، خليني احكي بطريقه ثانيه، او افضل احكي الموضوع بطريقه اخرى، اللي هي فيها this sulfonamide. This is the sulfonamide. طيب هلا as you can see it has an amine. اللي تعلمناه او اللي بتعرفون الامين is a basic functional group، لكن الامين لما تكون جزء من sulfonamide it becomes acidic. This amine is acidic. تمام. This is an acidic amine بينما this is a basic amine over here. ليش this is an acidic over here? Because it's part of the sulfonamide. It's part of the sulfonamide. طيب ليش هاي الامين is acidic لما تكون جزء من السلفوناميد؟ السبب انه السلفون over here is a strong electron withdrawing. Is a very strong electron withdrawing. And so basically this electron withdrawing pulls electrons from nitrogen. So the nitrogen lone pair are not really with the nitrogen anymore. They go to the sulfone and they stay with the sulfone most of the time. So that amine is an acidic amine. It's not very strong acid. It's a weak acid فعليا. So that amine under with base it can release a proton and we get this sulfonamide anion, which is like this. This is the structure of sulfonamide anion. NH لما نشيل بروتون راح نترك عليها negative charge. So this is under basic condition. تمام. So you can see this amine is an acidic amine as we can see. Should pK for this amine حكينا it's a weak acid in this case and the pK is about 10. تمام. The pK of this amine is about 10. طب شو pK الكربوكسيليك acid لما تكون جزء من benzoic acid؟ The pKa is 6.5. So which is a stronger acid? Definitely this carboxylic acid stronger than sulfonamide. تمام. They are stronger than sulfonamide. هلا that takes us to another point which is الامine. If I want to make this sulfonamide looks like papa more, what should I do? What should I do is basically to increase the acidity of this sulfonamide. إذا بحسن the acidity of this sulfonamide, I can make the structure look like or more similar toward this papa or para-aminobenzoic acid. How do I do this? By adding more groups over here to the amine that are electron withdrawing. تمام. When we have electron withdrawing, more electron withdrawing groups على الامine attached to it directly, then the amine becomes more acidic and becomes more like a carboxylic acid as we can see over here. Okay, so this is an important point that we should know. And this is يعني you will see these changes, these type of changes انه فعليا بنصير نضيف electron withdrawing على الامين وهذا بيحسن الاكتيفيتي بالسكند جنريشن اوف sulfonamide antibiotics. هذا الفيرست جنريشن او البيرنت كومباوند اللي هو السلفونيلاميد حكينا عنه وراح نشوف هلا انا little bit later. طيب لما نحكي عن نكمل structure activity relationship اللي بدنا نحكي sulfonamides الامين and sulfonamides group that are para to each other is very necessary for activity. لازم نشوف as we can see الsulfonamide هون والامين لازم يكونوا para to each other على الفينل ring to have an active compound. طبعا هذا similar للبابا او para aminobenzoic acid. The amine also in the sulfonilamide cannot be substituted. الامين اللي هون موجودة directly على الفينل ring you cannot substitute this amine. This amine has to stay فعليا with unsubstituted. This is the second important part of structure activity relationship. So two things عندنا لازم يكونوا para to each other. الامين اللي على الring also cannot be modified. You cannot add any functional group عليها. In addition to that, the benzene ring we cannot change anything on the benzene ring. If we cannot add substitution هون ولا هون على الأورثو أو meta positions, and this would cause a reduction in activity. هلا الامين if for example again we said we cannot change, so if I make it فعليا as an amide, this is less active. This is not good for activity, so you cannot do this. You cannot add anything على الامين. You cannot add anything على الامين. You cannot add anything على الرينجز هدول. The only change allowed in sulfonamides فعليا وين حكينا على هاي النيتروجين تبعت الsulfonamides. This nitrogen can have a substitution. So whether we add substitution to the amine, it's better to be electron withdrawing substitution to make the amine more acidic. And mono substitution, if you replace one of those hydrogens with just one substitution, will make an increase, will make a more active or more potent compound, which means you increase the activity and enhance the pharmacokinetic property. بينما لو حطيت two substitution, di substitution will destroy the activity. Why? Someone should tell me why. It's very easy to know why. لأنه في النهاية أنا بحتاج at least a proton على هاي الأمين تبعت السلفوناميد, at least one proton to make it acidic amine. لأنه الأسيدك أمين لازم يكون عليها proton at least one that you can take away and make this negatively charged amine زيه زي الأسيد. واضحة هاي النقطة؟ فأتوقع very simple. أمين لازم يكون عليها at least one proton. So only one substitution is allowed to replace one of those amines with other functional group. خلينا نشوف examples على هذا الحكي. So as we said, الأمين can be substituted, and scientists have predicted that developing sulfonamides with pKa closer to the papa, يعني خلي الأمين more acidic, as I said, would lead to more effective drug or more potent drug. Again, substitution of the sulfonamide nitrogen with an electron withdrawing group will increase the acidity, reduce the pKa, in other words, of this amine, and make it look like carboxylic acid أكثر. تمام? That's why all the second generation of sulfa drugs and those developed after sulfanilamide, which is the main parent compound, was established with an effective antimicrobial agent contain an essential pharmacophore اللي هي electron withdrawing additional electron withdrawing على الامين. اوكي. طيب شو فايدة الالكترون withdrawing اللي بنضيفها هون؟ بنخلي الامين more acidic, that makes the structure look like more of a papa, so that enhance the activity. بخلي الستراكشر ارتباطه اسهل على ال dihydropteroate synthase. In addition طبعا when you have a more negatively charged هون امين, stronger negatively charged امين, راح يحسن السوليبيليتي وراح يحسن الاكسكريشن of those compounds. طب انا ليش في نقطه مهمه, انا بحكي بحسن السوليبيليتي وبحسن الاكسكريشن. ليش هذا الحكي مهم؟ لانه الايرلي فيرست جنريشن اوف سلفونامايدز السلفينيلامايد, النيتروجين تبعته مش كثير اسيدك تبعت السلفونامايد. So these compounds specifically لما يكون ال pH تبعتنا more acidic pH زي باليورين, زي ال pH about 6 or less sometime in the urine, السلفينيلاميد لما كنا نعطيها للبيشنت, if it's absorbed راح يصير لها precipitation باليورين, it will cause damage to the kidney, and it will cause precipitation of stones and irritation for the kidney, and it will cause severe damage to the kidney. So all these second generation analogues صار عليهم تحسين, انه بخلي بقى more electron withdrawing, بخلي الامين more acidic, بضيف electron withdrawing على الامين بخليها more acidic, so the amine will be negatively charged حتى بالurine under acidic conditions, لانه this amine becomes very strong. The pKa تبعتها راح تكون 6 or less, حتى sometimes it's 5, and so this structure will be much more water soluble and more urine soluble فعليا, that doesn't precipitate in the urine, it gets excreted in the kidney, and that give it reduce the damage to the kidney with side effect or kidney toxicity that happens from the sulfanilamide. طيب شو في عندنا examples على drugs that have substitution على الامين فعليا that is electron withdrawing. عندنا sulfoxazole, which is one of the compounds where you have this heterocyclic ring, as we can see. This is an oxazole heterocyclic ring, that's why we call it sulfoxazole. This is the name of the compound. And the sulfadiazine. Sulfadiazine, you have an aromatic ring that's electron withdrawing attached to the nitrogen, and this aromatic ring is a bi-nitrogenous aromatic ring. And we have the sulfamethoxazole that has another oxazole ring, but it's a little bit different than the other one. It only has one method substitution, this oxazole ring مربوطة على النيتروجين. كل هدول الرينجز, الأوكسازول and this ring over here, all of them are strong electron withdrawing groups. So they withdraw electron from nitrogen, make this nitrogen more acidic, enhance the activity لأنهم بصيروا أكثر زي بيشبهوا أكثر البابا, وenhance the water solubility and reduce the kidney or severe side effects. شو في عندنا analogues موجودين of these second generations. We have sulfamethoxazole, as we mentioned. We have sulfadiazine. These are oral absorbable فعليا, so they can absorb through if you give them orally to the patients, and they can treat various type of infections. So these are orally absorbable compound of the sulfonamides, and they are, again, they have this amine, very acidic amine. We have topical compounds that are less polar فعليا, لأنه as you can see the substituent over here is not that polar, so the amide of this amine is less polar, so this sulfacetamide is given as eye drop, and this silver sulfadiazine, which is again the same as sulfadiazine بس هو silver salt تبع هذا الsulfadiazine, is used for topical application للبيرنز، ولحد اليوم مستخدم بالtopical application for treatment of burns to protect from bacterial infection. and this silver بتعطي السيلفر لاير بتكون موجودة من جزء من السيلفر سلفاديازين، بتعطي some protection from water loss from burns as well as protection from bacterial infection. بدي احكي عن اخر شيء اللي هو السلفاسلازين. السلفاسلازين is another sulfonamide compound. You can see this sulfonamide derivative over here that بس ينعطى للشخص orally. It can be used for treatment of intestinal infection. It's not going to be absorbed. It's only used for treatment of local GI infections. هلا في نقطة مهمة أنا بدي أحكي عن هذا الكومباوند sulfasalazine. This is not the main application of this compound for treatment of bacterial infection. هذا الكومباوند also can be used for treatment of inflammation, GI inflammations اللي خصوصا بالpatients اللي عندهم ulcerative colitis والCrohn's disease. What is the moiety that's responsible for this anti-inflammatory effect? It's not the sulfonamide moiety, لأنه بنعرف هذا structure هو an azo compound as we mentioned, and this is an azo. There is the azo functional groups we can see. Okay, this is the azo functional group. So this is an azo compound زي الازودايز اللي حكينا عنهم اللي هم very early discovered sulfonamides. So this compound is a prodrug. All of this compound is a prodrug. When it's given to the patients, لما يكون بالستومك ما راح يكون له أي effect وما راح يصير له أي تأثير لأنه بضل as a prodrug. When it reaches the intestine, البكتيريا اللي بالintestine by reductase enzyme, it breaks this diazo or azo functional groups and produce two structures, sulfonamide structure and this structure over here that we call 5-aminosalicylic acid. هو salicylic acid but it has an amine, it will have an amine, and I don't have to draw the structure but it's a 5-aminosalicylic acid. وأحيانا we call it as mesalamine, either way. So this compound is زيه زي salicylic acid صح؟ والsalicylic acid can be used for its anti-inflammatory activity. طيب أنا ليش ما أعطي الشخص directly 5-aminosalicylic acid يعني للpatients؟ لأنه ال 5-aminosalicylic acid زيه زي الأسبرين, it can cause irritation for the gastric mucosa, and so this is a prodrug that nicely can be given للpatients. ما راح يكون له تأثير بالgastric mucosa لأنه بيكون fully compound like this. It's not going to be absorbed, it's not going to have effect على gastric mucosa. When it reaches the intestine راح نكسر هاي الرابطة اللي azo by intestinal bacteria, and this 5-aminosalicylic acid will start working as anti-inflammatory activity in the intestine for treatment of patient of ulcerative colitis and Crohn's disease. So again, this sulfasalazine is a prodrug that doesn't cause irritation for the gastric mucosa زي الأسبرين مثلا. It's a prodrug. It's not gonna do anything in the gastric area or the stomach. When it reaches the intestine, البكتيريا تبعت الانتستين راح تشتغل وراح تحطم الكومباوند. The two compounds or two moieties, واحدة منهم راح تكون have anti-inflammatory activity that's necessary for treatment of ulcerative colitis and Crohn's disease patients. طيب يعني هاي اللي بحبني تعرفوا بالنسبة لمحاضرة الsulfonamides. Very simple. And you can see there's some compounds that have very nice applications, whether it's topical, oral application, orally absorbable compounds, and so on. And this is all what we need to know about sulfonamides for this lecture. طيب طيب آخر جزء راح نحكي عنه بهاي المحاضرة اللي هو Miscellaneous antimicrobial agents، وراح نحكي عن 3 different antimicrobial agents classes that are يعني very commonly used but they don't belong to any of the previous ones that we learned. أول واحد راح نحكي عنه اللي هو اللينكوسامايدز، وحكينا عنهم اللينكوسامايدز سابقا لما حكينا بنهاية محاضرة الميكرولايتس، بس راح نرجع نذكر فيهم بهاي المحاضرة لأنه يمكن ما حكينا عنهم كثير. بس إذا بتتذكروا حكينا عن اللينكوسامايدز إنهم فعليا they resemble الماكرولايتس in their mechanism of action and their spectrum of activity. In fact, they also have a mutual cross-resistance with macrolides because of their similar mechanism of action and similar spectrum of activity. They share the same resistance to macrolides. So if someone has developed resistance to macrolides or azithromycin, فعليا they will develop resistance to lincomycin, clindamycin, and this class of antibiotic that we call lincosamides. كيف بيشتغلوا هذول؟ what's their mechanism of action? Lincosamides bind to 50S ribosomal subunit and they inhibit the protein synthesis in bacteria. These are sulfur-containing antibiotics that are isolated from bacteria that we call Streptomyces lincolniensis, and this is you can see فعليا why we call them lincomycin or lincosamides لأنهم this is the name of the bacteria they're isolated from, and many times you see this in discovery of antibiotics from natural source بنسميهم على اسم البكتيريا اللي جبناهم منها. طيب هلا lincosamide structure wise they have a nitrogenous heterocyclic ring and they have a sugar unit that's unusual. ليش unusual؟ لأنه 8 carbon. فعليا عندنا هون 5 carbons and then you have 3 carbons additional attached. This is an 8 carbon nitrogenous, 8 carbon sugar. And then you have this heterocyclic ring, the pyridine ring attached to it. So this compound has an unusual 8 carbon sugar, and these compounds also have a nitrogenous heterocyclic ring اللي هي الpyrrolidine. It's weakly basic compound. However, this weakly basic is important because we can make salts out of it, and these salts make those compounds more easily administered for مثلا injections أو حتى orally administration will be probably easier. Lincomycin is an example of these lincosamides. The first one discovered for lincosamides, lincomycin. Later on, we made some semi-synthetic modification. With semi-synthetic modification was converting this hydroxy اللي هي بال 8 carbon sugar unit على convert with chlorine. So we replaced this hydroxy in the 8 carbon sugar unit with chlorine. And you see there's an inversion of stereochemistry. The hydroxy كانت on the left side, now it's on the right side. The chlorine is on the right side. Clindamycin is more active than lincomycin, and why it's more active because it's more lipophilic, so it can cross gram-positive bitter bacteria, and it has a better oral absorption or oral bioavailability لأنه it's more lipophilic than lincomycin. Chlorine is more lipophilic than hydroxy, and that's why clindamycin overall is more lipophilic than lincomycin. So clindamycin more bioactive and lipophilic, and more lipophilic than lincomycin, and thus it has a better absorption. Following an oral administration, it's about 90% absorbed when taken orally. Clindamycin works well for gram-positive coccal infection, especially in patients that are allergic to beta-lactams. تمام. So this is the first class. The second one we will talk about فعليا اللي هي chloramphenicol. Chloramphenicol is a compound that يعني doesn't belong to a specific class. It's part of those miscellaneous antimicrobial agents. It's produced by fermentation of Streptomyces venezuela, and it was the first broad spectrum فعليا oral antibiotic used in the United States in 1947, and at some point was very popular compound, but its use has dropped a little bit because of its toxicity. الكلورامفينيكول هنا لما بنستخدمه اللي موجود بالماركت هو عبارة عن compound synthesized in the lab. It was discovered from bacteria صح، بس هلا عشان نطلع منه كميات كبيرة بنلاقيه discovered in the lab. Synthesized in the lab. The structure, as you can see, has 2 asymmetric centers or 2 stereo centers. Only one of them will be active. هلا لما يكون عندنا 2 stereo centers, the possibility how many possible compounds you could produce. To produce 4 diastereomers فعليا أو 4 compounds يكون SR, SS, RS or RR. But only one of them is active, which is the RR بنسميهم derivative of this compound, which is the chloramphenicol structure that we can see. كيف mechanism of action of chloramphenicol? It binds to the 50S subunit, so it's similar to those previous compounds اللي هو زي Vancomycins. Chloramphenicol is a neutral substance, يعني فعليا ما في عليه charge. And it's highly lipophilic, as you can see, very highly lipophilic. طبعا النيترو charges اللي على النيترو هي بيعادلوا each other positive negative. فعليا هي not a real charge over here. So it's an uncharged compound, neutral. So it's very lipophilic with lots of chlorine, and this makes this compound very lipophilic. So there is a benefit of this. Small molecule lipophilic. لما يكون compound عنده هدول الخاصيتين هما small molecule lipophilic, it can cross the blood-brain barrier. So this compound can be used for treatment of bacterial meningitis فعليا because of its high lipophilicity. طيب آخر واحد راح نحكي عنه فعليا of these compounds اللي هو these miscellaneous compounds اللي هو Vancomycin. Vancomycin is a natural product produced by a fermentation of bacteria that we Amycolaptosis orientalis, and this bacteria produces this vancomycin, which, as you can see, this is the structure of vancomycin. It's been available for use for the last 40 years. However, its use has increased over time because it can treat methicillin-resistant Staphylococcus aureus and other multiply resistant staphylococci. So أهمية الفانكومايسين فعليا إنه can treat various bacteria that can be treated with other antibiotics when you have resistance, specifically زي الميرسا. Vancomycin is a bacterial cell wall biosynthesis inhibitor, and structure-wise you can see it's a peptide-like structure. ولما نحكي peptide هاي peptide bonds you can see اللي هم الإمايز over here 1, 2, it's hexa. If you count them, there's 1, 2, 3, 4, 5, and 6. So there's 6 peptide bonds in this structure. You can see it's a very large structure, big structure. It's very lipophilic, عليه sugar units as well. And so this structure cannot be given orally for systematic infection. So you cannot treat systematic infection with this compound. And so, as you can see in this structure, if it's very large, it's very polar, it doesn't get absorbed by oral. So you can only give it by intravenous infusion. ولما نحكي infusion مهم جدا نعرف إنه هذا الكومباوند بنعطى by intravenous infusion مش bolus injection. And it needs to be given over long time, 30 minutes or more. ليش؟ لأنه one of the known side effects for this compound is it causes a histamine release or histamine rush. إذا أنا بعطي بسبب حساسية فبيكوز syndrome we call red man syndrome. So this is one of the side effects in addition to nephrotoxicity that could cause this compound. بس هو الكومباوند مهم جدا استخدامه حاليا وزاد استخدامه لأنه it can be used for treatment of فعليا various gram-positive bacteria that are resistant for other antibiotics or that are multiply resistant for other antibiotics. They multiply resistant staphylococci, زي الميرسا, which can cause septicemia, endocarditis, skin and soft tissue infections, and other infections as well. ممكن نعطيه orally, can be given orally, but only for specific case, which is Clostridium difficile. This type of infection, this is an overgrowth of this specific type of bacteria, and which causes diarrhea. وهي بالعادة it's an outgrowth of bacteria after following an administration of a broad spectrum antibiotic. As a opportunistic growth of this Clostridium difficile. ممكن نعطيه orally vancomycin for treatment of this type of infection for this GI infection فعليا فقط local infection. طيب إذا هذا الكومباوند أهميته mostly you can see that it can be used for treatment of staphylococci and multiply resistant اللي هو عفوا methicillin resistant staphylococcus aureus. طيب هيك بنكون انهينا هاي المحاضرة وانهينا الانتيبيوتيك بارتس. إن شاء الله المحاضرة الجاي بنبلش بتوبيك جديد، وإذا فيها أسئلة إن شاء الله بنحكي فيها بمحاضرة اللايف. يعطيكم العافية.